Hello, welcome to a short tutorial on absolute value functions. In this tutorial we're going to, first of all, we'll graph y equals absolute value of x. We'll use our TI calculator. It's in the math menu and we'll see it makes this sort of V shape. And if we write it as a piecewise function, we can see why this is. Basically, it's equal to positive x when x is greater than 0 and negative x when x is less than 0. So what you're getting is basically a mirrored image. And you get the negative slope version on the left side and the positive slope version on the right side. It's called piecewise notation. So it's sort of composed of two different pieces and has an axis of symmetry down the middle at x equals 0. So that's our standard function. We're going to look at a more complicated one. Let's say they asked us to graph and write in piecewise notation a function like f of x equals, say, 2 times absolute value x plus 3 minus 4. So we'll work with this graph and just box that off so it doesn't get in the way. As a transformation, we could look at this and say that 2 is sort of like the slope of the function on either side. Basically makes it a little bit steeper, up 2 and over 1. The 3 makes it go left 3. The 4 makes it go down 4 units. Very similar to what parabolas did with the h and k values of the vertex. What you can do, once you put the vertex down there, you just go up 2 over 1, up 2 over 1 on either side, and you generate your V shape. And notice it's a little steeper than the one we used that we got from our graphing calculator because the slope is 2. Anytime you want to find an axis of symmetry, you just take what was ever in those brackets, those bars, and set it to 0. In this case, it becomes x equals negative 3. So you have to cross the equal sign, and the sign seems to switch. Now, if we want to write this in piecewise notation, you can just see on the right side that it's 2x plus 2, knowing y equals mx plus b. But we could do it algebraically, and basically what happens is you just treat the bars as if they were regular bars, and then you isolate, kind of collect like terms, and there you go. On the other side, you have to do the opposite. So you have to put an opposite sign in front of the bars and go through and find that equation. And notice that that negative 10 is what the y-intercept would have been had that negative sloped line made it all the way to the y-axis. It can't, though, because it says it's only true when x is to the left of negative 3. So we can take this a step further and solve an equation. Let's say we were asked to graph a new function g of x equals to 6. So that's just a horizontal line. Basically what you're trying to do, if they say solve this equation when it's equal to 6, is find the points of intersection between the blue absolute value function and the red line. So first of all, what you do is you just treat it like regular brackets. Distribute, collect like terms, you end up solving for x, you get x equals 2. We can see on our graph that x equals 2 is a point of intersection. Then you do the same thing, but you put the opposite sign in front of the bars. So you have to consider the other side where you had a negative slope instead of a positive slope. So we go through, we solve this equation, and we get x equals negative 8. And again, we can see on our graph, x equals negative 8 works. It is a point of intersection. So it's nice to see a visual of what we're actually solving algebraically. Basically what you're doing is on one side, you just treat it as sort of the normal case, where you just pretend those brackets are regular brackets, and on the other side you put the opposite sign of whatever you just did. So you check both sides, you should get two different answers. Thanks for watching.